So continuing, I want to talk about divisors of a natural number. And we have a couple bits of information in this theorem here. And I want to look at the number 12. So the example here is going to deal with 48 and 54, but I want to look at the number 12 and walk through this theorem about the divisors of a natural number. 12 is 2 to the second power times 3. If you were to do a factor tree or use that second method with the division, you're going to find 12 is 2 to the third times 3. That's its prime power factorization. This theorem says that the factors of, or all the divisors of 12 are created from these prime factors. So let me give you a for instance. 2 times 2 times 3 is what we have here. If I just consider 2 times 2, 4, because that's made up of 2 of these prime factors, that's also a divisor of 12. If I look at 2 times 3, 6, that's also a divisor of 12. 2 times 5, for instance, since 5 is not one of those prime factors of 12, 10 is not going to be a divisor of 12. So all of the divisors, all of the numbers that divide into 12 are formed based on these prime factors. So that's part of what this theorem says. The other part of what this theorem says is it gives us the total number of divisors. The way you find the number of divisors is you're going to take the exponents for each of the prime factors and add 1 to them. So we have 2 plus 1, that would be 3. And 3 is technically raised to the first power, we just don't write it. So 1 plus 1 would be 2. So again, the second thing that this theorem says is it gives us the number of divisors. So it's going to be 2 plus 1 times 1 plus 1. So 3 times 2. So that tells me there are 6 divisors in 12. 12 is divisible by 1 and 12. It's also divisible by 2 and 6. And it's divisible by 3 and 4. So you notice I've got them written in pairs there. How many divisors are there in 12? There are 6 different numbers. So that's what this theorem is giving us. It's giving us 2 bits of information. Now, when we're dealing with relatively small numbers, we can approach this in a bit more straightforward manner. So if I'm looking at a number like 48, and I want to list the divisors, probably the easiest way is to do it like this. 48 is 1 and 48. It's also 2 times 24. Also 3 times 16. 4 and 12. 5 does not go into 48. 6 does. 6 times 8. So there are all of the divisors of 48. You can do the same thing for 54. 1 times 54. 2 times 27. 3 times 18. 4 does not go into 54, neither does 5, but 6 goes in 9 times. And that's it. So those are all of our divisors for 54. The largest common divisor, the largest number that these have in common, is 6. So our largest common divisor here is going to be 6.